Hello students, in this video I am going to discuss about properties of convolution sum. So in the last video we discussed the derivation of a convolution sum. So here we are going to discuss about the properties of convolution sum. So we have three properties for convolution sum. The first one is commutative property. Second one is associative property, and third one is distributive property. So these are the three properties of convolution sum. So we take one by one. The first one is the commutative property. So the definition of commutative property is x of n convolved with h of n is equal to h of n convolved with x of n. So this is the property. Now we have to prove this. Let's take the proof for this. So from the definition of convolution sum, x of n convolved with h of n is written as summation k is equal to minus infinity to plus infinity x of k h of n minus k. Call this as equation 1. Now here I am replacing this n minus k with a dummy variable m. So replace, sorry for that, replace n minus k is equal to m. So I am replacing n minus k with m. Since we have k varying from minus infinity to plus infinity, so this must be derived. So then what happens to k? So k n minus k is equal to m here. Now we just replacing n minus k with m here. Then what happens to the limit is, so here it becomes n. So what happens to k? So n minus k is equal to m. So k is equal to m minus n, or if we multiply with this, so k is equal to minus m plus n. Okay. Now the limit should be as we have changed n minus k with m. So what happens to this limit? K will be equal to minus m plus n. Now if I substitute that, so this is what I will going to get the limit as minus m plus n is equal to minus infinity. This is the lower limit. So minus m is equal to minus infinity minus n. So if you multiply by minus, you will get m is equal to plus infinity plus n. So anything multiplied with infinity, you will get infinity itself. So m is equal to plus infinity. So this will be the lower limit, and then what happens to the upper limit? So the same thing happens to upper limits, and it will get my m is equal to minus infinity. So this will be the limit. So the limit won't change, it will remain as it is. So using all these terms, we get the equation x of n convolved with h of n is equal to summation m is equal to plus infinity to minus infinity. As you can see here, we have x of k. So k is equal to what? Minus m plus n, or this can be written as n minus m here. So, we have defined this for k, and here we have x of k that will be replaced by this term. So, then it becomes x of n minus m. I am just rearranged it, and n minus k is replaced by m. So, I will get h of m. And if you look at the limit, it is varying from plus infinity to minus infinity. So, it will not matter, it will remain the same. I am just rewriting the expression, m is equal to minus infinity to plus infinity h of m x of n minus m. Okay. So, give a equation number for this 2, and to the RHS we have LHS we have x of n convolved with h of n. Since m is a dummy variable that we have considered here, n minus k is equal to m. Now, we can just for convenience, I am replacing this m with k, replacing m with k. So, why we will come to know. Then the equation will become k is equal to minus infinity to plus infinity h of k x of n minus k, and here we have x of n convolved with h of n. Now, if you observe from the definition of convolution sum, it says x of n convolved with h of n here. X of n convolved with h of n is equal to summation k varies from minus infinity to plus infinity x of k h of n minus k. In the same way, if you observe equation 2, equation here, this equation, in place of x of k we have h of k, in place of h of n minus k we have x of n minus k, and the summation with limit are the same. So, now we can write it is similar to the definition of convolution sum. So, we can write this part as h of n convolved with x of n, and to the LHS we started with x of n convolved with h of n. So, this proves commutative property. Okay. So, let us take the next one, that is associative property. So, the definition of associative property goes like this: x of n convolved with h1 of n convolved with h2 of n is equal to x of n convolved with h1 of n convolved with h2 of n. So, this is the definition of associative property. This is the property definition. So, let us take the proof for this. So, just before going to this, let us define these two terms here. Let x of n convolved with h1 of n is equal to f1 of n, and here the second one, h1 of n convolved with h2 of n is equal to f2 of n. So, these are the two things that we have defined. Then what happens to f1 of n? So, then f1 of n is equal to summation k varies from minus infinity to plus infinity x of k h1 of n minus k. So, this we have written by using the definition of convolution sum. Then what happens to f2 of n? So, f2 of n will be summation k is equal to minus infinity to plus infinity. Here we have convolving h1 of n convolved with h2 of n. Then it will goes like this. Since I have used x of k h1 of n minus k, I will be using a different alphabet just to make just to make a difference between these two expression. So instead of k, I will use some other alphabet, say r. So r is equal to minus infinity to plus infinity, h1 of r, h2 of n minus r. So you can compare these two. So these both are similar, but here k representing the time shift and here r represents the time shift. Okay. So now we'll start with the left hand side of the equation, that is the statement of associative property. So what does it say? X of n convolved with h1 of n convolved with h2 of n is equal to f1 of n convolved with h2 of n. So why I have written like this? Because as you can see here, the x of n, h1 of n, we have defined it as f1 of n, and the h2 of n I am writing as it is. Okay. So x of n convolved with h1 of n whole convolved with h2 of n. So this one is f1 of n and this one is h2 of n. Now what happens to this? f1 of n convolved with h2 of n. So from the definition, we can write it like this. Since I am already used k and r here, I am using a different alphabet just to mention represent the limit and the time shift. So m is equal to minus infinity to plus infinity, f1 of m and h2 of n minus m. So observe, this is similar to the definition of convolution sum. I have just changed the alphabets for making a difference between them. Okay. So now you can see this. We have defined f1 of n here. I can give a name for that as well. Here, so we are not given any equation, just one, and in associative property we have not given any name. So just give it equation 1 here, and for this one equation number 2. Then what happens to this? We can substitute that equation 1 here, but here in place of f1 of n we have f1 of m. Just replace n with m, so you will get in equation 1 you will get the expression. Now I am going to substitute this here, substituting equation 1. So what happens to this expression? Summation m is equal to minus infinity to plus infinity, and I am substituting f1 of m here, that is summation k is equal to minus infinity to plus infinity x of k, h1 of, since we have m here I am just writing it as m minus k, and this h2 of n minus 1 I am keeping as it is. Okay. So just I'm just showing this once again. X of k, h1 of n minus k have been substituted. Since here f1 of m is there, I have replaced this n with m here. So that is that. Now I will just make changes for this m minus k here. I will replace that, or I will substitute r is equal to m minus k. Why means, for the convenience of the derivation I am using the same alphabet r which I used for f2 of n. The limit r is equal to minus infinity to plus infinity. I am using the same one here. R is equal to m minus k. Okay. And here you can see this, I am just interchanging the summation, order of the summation. So these two summations I am interchanging the order, and also I am replacing r with m minus k. So as in the commutative property, when this term has been replaced with some alphabet, the limit will also change here. Now which limit I am changing here is, since this is m minus k, I am not changing this limit, I am changing this, because this x of k will become constant with respect to this. So that's why I am taking this out, that is the interchanging this order, and I am using this summation here. Now this summation with m varying from minus infinity to plus infinity, this will be replaced by the another alphabet, that is r. Now how it will look like, uh, r is equal to m minus k. So if you take like this, so what happens to m? M is equal to r plus k. Okay, so m becomes r plus k, and if you substitute here m is equal to r plus k, r plus k is equal to minus infinity. So r is equal to minus infinity minus k, that means r is equal to minus, the limit will remains the same. Okay, so I am just showing you once again, and the same happens to the other side. So the limit will be lower order and upper order limit will remains the same, r is equal to minus infinity to plus infinity. Okay, this is just for clarification I have written. Now the equation will look like this. So I am taking the first summation, k is equal to minus infinity to plus infinity x of k. So this one I am writing, this expression I am writing first. Now the order has been changed here. Summation r is equal to minus infinity to plus infinity. So this has been removed. This will varying from r is equal to minus infinity to plus infinity. This h1 of m minus k, I am replacing this with r. So that becomes h1 of r. And here, if you can observe, I have h2 of n minus m. Now m is equal to what? R plus k. If you substitute that, it will look like this: h2 n minus of r plus k. Okay, so that completes the substitution. Now if you multiply with minus, you will get summation k is equal to minus infinity to plus infinity x of k, summation r is equal to minus infinity to plus infinity, and don't forget this, this is a different part, h1 of r, h2 of n minus, just for simplification purpose, n minus k minus r. I am just rearranged it and written multiplied by minus. So this is the way, this is the simplest form of that, and I give a equation number. Since we have start with 1 and 2, let's give it equation number 3. Okay, and to the LHS we have x of n convolved with h1 of n convolved with h2 of n. Okay, so now in the beginning we have defined f2 of n is equal to summation r is equal to minus infinity to plus infinity h1 of r, h2 of n minus r. Okay, now if you observe this, we have same limit r varying from minus infinity to plus infinity, h1 of r same is there. Here n minus k minus r is there instead of n minus r. So that means we have a time shifted input for this. So then what happens to this? If f2 of n gives like this, then to get h2 of n minus k minus r, I'm just we should replace n with n minus k. So that then the equation will look like this: r is equal to minus infinity to plus infinity h1 of r, h2 of n minus k minus r. So you just observe these two. F2 of n, we have h2 of n minus r. If n is replaced by n minus k, this n also replaced by n minus k. So then nothing will be affected. So it will be the same as the equation of convolution sum itself. So why I am making this? Because I am going to replace this entire term in equation 3 with f2 of n minus k. So let us see what happens to equation 3. So therefore, equation 3 becomes, so equation 3 will look like this: summation k is equal to minus infinity to plus infinity x of k, and this entire term which is present in equation 3, you can see, so that will be replaced by f2 of n minus k. Now if you in the LHS we have x of n convolved with h1 of n whole convolved with h2 of n. So now if you compare this with the definition of convolution sum, we have same limit k varying from minus infinity to plus infinity. We have x of k. In place of h of n minus k, we have f2 of n minus k. So this can be written like this: x of n convolved with f2 of n. Okay. So x of n convolved with f2 of n. Now, what is f2 of n? In the equation 2, we have defined f2 of n as h1 of n convolved with h2 of n. So, therefore, if you substitute that, f2 of n will look like, will become h1 of n convolved with h2 of n. So, this is how we got this, by equation 2. Okay. So, to the LHS, we have x of n convolved with h1 of n convolved with h2 of n. So, hence this is the proof of associative property. Now, coming to the last one, that is a distributive property. So, this is the distributive property. The definition says x of n convolved with h1 of n plus h2 of n is equal to x of n convolved with h1 of n plus x of n convolved with h2 of n. So, this is the definition of, or the statement of distributive property. So, let us take the proof of it. So, to take we start with the LHS of that: x of n convolved with h1 of n plus h2 of n. So, this is equal to, let us apply the, from the definition of convolution sum, k equals minus infinity to plus infinity. You observe this: x of k is kept as it is. Now, this h1 of n plus h2 of n. So, that can be written like this: h1 of n minus k plus h2 of n minus k. Okay. So, the definition says x of k h of n minus k, since we have x of n convolved with h of n. So, now, so this summation and x of k is multiplied with this. So, what do we get here? Summation k is equal to minus infinity to plus infinity x of k h1 of n minus k plus summation k is equal to minus infinity to plus infinity x of k h2 of n minus k. Now, if you observe these two expressions, uh, they are similar to the definition of convolution sum itself. So, based on that, we can write this expression as x of n convolved with h1 of n plus the second part can be written as x of n convolved with h2 of n. So, to the LHS, we have x of n convolved with h1 of n plus h2 of n. So, this proves the distributive property. Okay. So, along with these three properties, we have some more properties of convolution sum which we are going to use in the while solving the problems. So, the first one is apart from these three. So, if x of n convolved with delta n and delta n convolved with x of n, so the end result will be x of n itself. So, this is one property, and the second one is when x of n is convolved with a time shifted version of impulse response, so you will get x of n minus k itself. And the third one is when two time shifted version delta n minus m delta n minus k, when two time shifted versions are getting convolved, so then the end term will be delta n minus of m plus k. So these are the other three properties to remember. This will make use while solving the problems. Okay, so that's it for this video. In the next video, we'll take some examples on convolution sum. Thank you.